table. So let us discuss some more examples of the tables that we can create in an SQL statement. So let us consider another table structure. The table structures will be given by the database designer, and the database administrator has to write that statement. This is the column name. Data type and the constraints that we want to put. Now one is account number. Data type is given as number of size 10, and there is no particular constant is given for this one. And another is customer ID. Now generally what happens that account number is considered as a primary key, but in this case it may happen that a particular customer may have more than one account. At the same time, one account may have multiple numbers of customers, that means the joint account. So that case the account number cannot be a primary key, but we can consider both the combinations, that is account number and customer ID combinations, as a primary key. So it should be a composite primary key. Now we have to put the constraints of composite primary key in this case. So how to create the composite primary key during the DDL statement at the time of creation of this table? Let us see. So what should be the DDL statement for this one? Should be create table, and the table name, suppose bank info. Account number, as I am considering PostgreSQL, so I can consider this one as an integer. And if I want to put one additional constant, that is not null over here, because as it is a column level constant, we can put this constant over here directly. Then customer ID. That is also not null constant. Now this composite primary key should be a table level constant. So after creating this table, two table and their data type, after that we can go for the composite primary key constraint. So I am putting one constraint, and after that one optional part is there, you can put the constraint name also. So I am giving the constraint name as bank info pk. This is constant name, actually this is constant name. Now I am giving the primary key as account number, comma, customer ID. That's it. Let us consider another example. This table is employee table details. Now I am creating one big table. Now this one is column name, data type, and the constraint. Now you know more or less that how to create the column and with the data type, but how to put the constant, which one to be considered as the column level constant, which one to be considered as the table level constant, that is more important at the time of creating the DDL statement. So this one is primary key. Next, suppose employee name work at 2:30. Employee email that is also work at 2:30. Department, that is number of size 2, and the default value is HR. That constant we have to consider. Manager ID, look at this manager ID should be same as the sum of the employee ID, and we have to take care of this one, that out of this employees, some of the employees will be the manager. And those manager will refer to the employee ID column. So here it should be a foreign key. It must be a foreign key that refers to the employee ID of employee table. These are the condition given for this particular table. So let us see how to create the DDL statement for that one. So you can write create table, then what is the table name I have considered, that is employee, right? Create table employee, so first is the EMP ID and it's the primary key, not null. So EMP ID, either you can take integer if it you are taking it as a PostgreSQL, so it should be integer. Then let us put the constant not null is one constant, then primary key. The next is employee name and no constant is given for that one. EMP name work at 2:30, no constant is given for this one. And then employee email work at 2:30, employee department department name, and it should be it should not be department name, it should be department ID. Department ID number 2, and if you are using PostgreSQL you can give ID integer. Now here you have to give the default value, so you can write here default, then within single quotation HR. Next is the manager ID, right? MGR ID, and that value, that data type should be same as this data type. And this one, look at this, this constant is a table level constant, because it is associated with two column, one is the manager ID, another is the employee ID. So this we have to write after writing this column name and its corresponding attribute data type. Okay, now I will put the constant details. I will put the constant details over there. So constraint, you can give the constant name also, fk, then foreign key, this one is constant name, foreign key, then which foreign key I have to consider, that is MGR ID. MGR ID references employee is the table name of EMP ID, that's it. So this line, which is a table level constant, will refer the primary key of the same table. Actually this is called self referential integrity constant. I hope this one is clear. So let us consider another more little bit complex one. Column name, then data type, then whatever constant is given. Now in this case actually it's an item table. Okay, it's an item table. So what are the items are there? One is item ID, work at 26, then it should be not null primary key, constant is not null and primary key. Another is item name, wait, not null. Quantity in hand, I am writing in short that QTI in hand, that is number 3 should be greater than the reorder level. I will explain what is that actually. Should be greater than reorder level. Unit price, that is number 6, and unit price must be a positive value, positive integer, positive integer cannot be negative. Okay, fine. Then class of the item, and that is fixed character 1. Now the condition is given, class of the item is A if price is less than equal to 100, B if price is less than equal to 1000, C if price is greater than 1000. This condition, whenever you are creating this DDL statement, this is very important, how to implement this statement. And look at this must be a table level constant. Why? The class will depends on the price I am giving, that is the unit price I am giving, and unit of measurement. Work at 212 reorder level, that is integer and must be greater than 0, or it must be a positive value, positive integer. Reorder quantity, an integer must be greater than 0. So this is the entire table structure. Now let us create it step by step. So create table item, and first is item ID, I suppose, and it is worker to 6, right? Worker to 6, it's a not null as well as primary key. Next, I think item name, and it's a not null, nothing else. Work at 230, not null. Next is quantity in hand, and that should be greater than reorder level. So already I told that how much quantity I have, and I have to check always that there should be some threshold value. If it goes beyond threshold value, you have to order that quantity. So suppose the reorder level of a particular item is 6, that means my quantity is right now 10. So every time when the quantity value is there, it will check that whether it is greater than reorder level or not. If it is not there, that case we have to order that item, so that there should be a sufficient amount of item which should be within my stock. So that quantity, its constant must be dependent on the reorder level, so it's a table level constant. So right now we will write the attribute name as well as the data type, and later on we will put that constant at the end of the table. So it is quantity in hand, right? Quantity in hand, and it's work at 230. So what is the next condition is given, that is the unit price, and that is should be a positive integer, and it's a column level constant. unit price integer, and we can put the constant, and it's a check constant, then constant name price ck, this is a constant name. Now we are putting the check constant check, then unit price greater than 0. So what is the next one? Class of the item, right? Class, and it's also a table level constant. I will put that constant later on. So class, its character 1. Then unit of measurement, varchar 2 30, then reorder level, that is the threshold level that we have already discussed earlier, that is integer. Now reorder level also must be greater than 0. So this is also column level constant, we can put it over here. So constraint r order level, this is the constant name. Now check reorder level must be greater than 0. What is the next one? Reorder quantity. Reorder quantity, must be integer. Again this one also a column level constant. So let us put the constant r order quantity, then check reorder quantity greater than 0, then discount integer. Now all the I think discount I have not given over here, so let us not consider the discount right now for the time being. So all the columns or attribute names have been entered. Now let us check that what are the table level constant, we find it out. So this one is one table level constant, so this one is one table level constant, we find it out. Another is this one. So two table level constants are there. So first constant is that the quantity in hand must be greater than the reorder level. So it should be reorder level. Now again I am putting the constraint QTI r order level. So this is my constant name. Now I am putting the check constant, that QTI, what is the exact name? Name is QTI in hand, quantity in hand must be greater than reorder level. So this is one table level constant. Another is the table level constant is that class of the item. So another constant CK, class check. Then let us put the check constant check class equal to A and unit price greater than it should be greater than equal to unit price greater than equal to 100, not greater than equal to 100, it should be less than equal to 100, then next one is class equal to B and unit price between 101, this one should be or unit price between 101 and 1000, or class equal to C and unit price greater than 1000. So these are the conditions they ask for. So if it is done, then my entire table will be created with that particular constant that we specified over here.